Test 1 2 3. Test 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 test. 1 2 3. Test. Looks pretty good. Maybe. Test 1 2 3. Okay, that's probably good. This is too chill.
You're listening to the NTS Guide to 16s and genres, past and present.
Okay, that's probably good. Guessing it was this one. Solaris, if you're there, was it 1064? Okay. I'll do 03. Gives me a minute. Because it has been multiple weeks since I've even done any C++. There's a Cheyenne video on Centro Decomp. Oh, that's cool. Can you link the channel? Because I actually don't know who that is. Or maybe if I see it, I'll probably know who it is. First character can represent 1 bit 0. Second character can be represented by 2 bits 1 0 or 1 1. What? Oops. Dynamic minimum spanning tree. What was the deal with that again? I know offline you can do, is it Gomery Who? Is that what it's called? Yeah. And you can do like dynamic max flow queries with it. I don't know what, I don't remember what this is. Maybe that's what this is, I don't know. Okay, where was I? What do we got? Same difference. You've been staring at your computer screen for too long. It's time to get a break and go touch some grass. Your screen is a line of length A. There are end tabs displayed on it. Oh my god, I'm rusty. You want to close all tabs by clicking the X's at the right endpoint. Every tab is a segment of length minimum of either B, which we're given, or A over M, where M is the number of remaining tabs. Okay, the tabs are always tightly arranged in sequence from the left endpoint of the screen. That is, the X's will be at length, 2 times length, 3 times length, and so on, M times length. So they're all the same length. Please note the length for each tab will change as you're closing tabs. Now your cursor is at the left endpoint of the screen. You wonder the minimum number of times you need to move the mouse. Oh, okay. Well, I've run into this exact situation enough times that I know exactly what it's talking about. So you make a bunch of tabs until you go off the edge. That's what B would be, right? B is like the minimum length, so now it's like there. So if we're at the end here, like you just click, 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 right up until you reach... I guess there's no maximum, right? Or is there? Must be, right? Here there's a maximum. If there was no maximum, you would just keep going. You would just click the X's over and over again. So I think I'm missing something here. It's the min of these, so why would it not always be 1? Here it's 2. 9, 6, 2. We have 2 tabs. The length of the screen is 9. B is 6. So therefore the tab spots are at 6 and 12. But wouldn't you would close the first one. And then I guess it would go to 9. Is that how that would work? It would say, well, now this doesn't need to be a length of 6. This can just be a length of M over 1 because there's one thing left right here. No. No, I have this backwards. If it's the minimum of... Let me think about this. If it's the minimum of B and that... Oops. Then this phenomenon I'm talking about... Okay, that was the wrong hotkey. This phenomenon I'm talking about here... B would not be the minimum tab width. B would be the maximum tab width. So actually this doesn't exist. You'll always be able to click this X right up until you get to the maximum tab width here. And then you would say, okay, how many are there? So here it's not that it would be 6 and 12. Are the... Let me pull up Excalidraw. I am so unbelievably rusty. 1102. That is the last time I've opened Excalidraw. Good lord. Got plug her in. Okay, so this is the window up here. So you have the 3 little dots because I'm on a Mac, and then you have all the tabs. So the moment you pass this, they're just going to compress. Right. And then you just click the X right up until they stop compressing. So that would be when you get to here. Then you would say, well, now B is like maxed out, so I need to click that. So I think you would look for what's the maximum number of tabs that I can have open. What's the minimum number of tabs I can have open where it will be exactly here. And then I click this a bunch of times until it's just these remaining ones. And I feel like there's going to be a lot of times where if B is like equal to A or something like that. I'm guessing that's what happened. That's what's happening in example 1. Let's see. We're given A, B, and N. So B is 1. A is 8 and N is 6. So why would that work? Let me close this. Because wouldn't that be each of these has to take up 1? right? Let me get rid of some of this stuff. Oh wait, I just started on question B. Okay. That's good, because I feel like I'm like, wow, a question A, I'm really spending a lot of time on this. But this just makes me feel less bad. So 8, 1, and 6. B is 1. Oh, because I guess you would just always click on the beginning, right? You would just click this X over and over and over again, and then they would all shuffle down, because they're never going to change in length. And in fact, I'm actually noticing there's only 1s and 2s, so maybe my strategy of clicking on the end is not really valid. Maybe it's actually the opposite. You only click on the beginning. Does that make sense? I don't think so, because wouldn't it would change length a lot. No, it's only going to be 1 or 2. So you would click... Let's say you had one that was like... Just it was filled all the way. So you have this, 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 and this is the end of it. So in this case, let's say you click here, you get rid of this, then these redistribute. And then you click this again, and then let's say these redistribute, but they don't redistribute all the way. They redistribute to like that or something. Then you can click here a bunch of times. So the answer is only ever going to be 1 or 2. What's the world where it's 1, and what's the world where it's 2? Well, if B is... I guess if the length of it never changes, that's one case where it's 1. Or if the length of it always changes, but B is greater than or equal to A, then the answer will always be 1, because the end will always have a valid X. So B is greater than or equal to A. It's this, or the length of a box never changes. What's the world where the length of a box never changes? I think that's if B is the constraint. So if B is less than or equal to A over M. So here, if this were 6, 1, 6, you'd be fine. If this were 5, 1, 6, I think then you'd say the length of each box is now 5/6. 5/6. So, or B times N is less than or equal to A. And with that, I think I'm ready to just code this bad boy up. And then otherwise it's 2. Okay, we get A, B, N. Okay. Res is something. Print res. I don't really need to print anything else. B is greater than or equal to A, question mark, 1, or else B is less than or equal to, B times N is less than or equal to A, question mark, 1, or else 2. Am I going to have any overflow issues? Yes, because B times N could be gigantic, so. That should fix that. Okay, let's see how it runs. 1 2 1 1 1 1 2 1 2 1 2 1 1 2 1 1 1 1 2 1 2 1 2 1. Seems pretty good. Let's get rid of this guy. I feel like I'm missing something. When would this not work? I don't care. Okay, good. My reasoning was that if A over M is the minimum, then you click on the right. If B is the minimum, you click on the left. So you output 2 if the min ever changes. So when B is inside the interval... Yeah, exactly. Yeah. Those are a similar thought process to mine. Even a string s of length n consisting of lowercase letters in one operation, you can select an integer I and change s sub I into s sub I plus 1 with the minimum number of operations to make every character the same. So I guess you would just look at the last character and say, what's the closest thing to that? Or you would really just say how many characters aren't that. So here it would be 1, here it would be 0, here it would be 2, here it would be 4, here it would be 4. The easiest A I've ever seen. Yeah, this is pretty easy. I was like, man, I'm rustier than I thought. I mean, I didn't know how rusty I was, but if I was struggling with A, like this is more what I was expecting. So we just got the length and then the string. Let's get a counter for char. For character C in S. No, I'm not even going to do that. I'm just going to say int res equals 0 for char C in S. If C doesn't equal S at n minus 1, res plus equals that. No need for branches. How does this do? 10244. Okay. No bullshit character casting problems. Easy dub. Cycle merging. Well, maybe. Okay, yeah. You have an n non-negative integers, a1 through n arranged on a ring. AI and AI plus 1 are adjacent, a1 and an are adjacent. You need to perform the operation exactly n minus 1 times. Choose any pair of adjacent elements on the ring, let their values be x and y, and merge them into a single element of value max of x and y with cost max of x and y. Okay. The minimum total cost to merge the ring into one element. I think I'm missing something. This feels a lot like A, but I can't imagine it is. Oh, I see. This will decrease the size of the ring by 1. Well, why does that matter? I don't understand. This seems almost exactly like A. So if my intuition's correct, you'd say 1, 1, 3, 2. Everything has to be 3. There's no way to get rid of a 3. So you would merge the 3 with a 2. Okay. Because you could merge the 1 with the 1 and just say, I know that this has to turn into a 3, but I'm just going to delete one of these right now. Maybe try D first. It's the most interesting problem. I want to think on this one. I mean, the two immediate things that come to mind are some kind of DP formulation or some kind of greedy formulation where you just like destroy the smallest element every time, or you find the two elements where the maximum is the smallest and you destroy that. Because I guess if you're going to destroy one of these ones, you know it's ultimately going to cost 3. So like here, you would immediately merge all these ones together, because you don't want to merge them with the 4. So you would have 1, 2, 3, and then you'd have 1, 4, 5, 1, 4. You'd merge a 4, you'd merge a 4, if you're up to a cost of 11, and then you'd merge a 4 again. No, is that right? 1, 1, 4, 5, 1, 4, 1. So you'd say merge this one with the end, get rid of that, you're up to 1. Merge this at the end, get rid of that, you're up to 2. Merge, I guess, this one with a 4 and this one with a 4, so you're up to 10. And now you have 4, 5, 4. Right? Yeah, and then merge the 2, 4 together, so now you're up to 14. And then merge the 5 with one of the 4s, you're up to 19. So I guess just always merge the smallest thing. So I feel like you could use some kind of like monotonic stack with this. I mean, it's not super apparent to me, like, how you parse this, like, even with this greedy formulation. I mean, is it though? I don't know. It actually seems pretty simple. You just have a left and a right pointer. You'd say keep your left pointer, or they both start at like here and here. And then while they're not the same, either this goes up and you get rid of this, or this goes down the first time it wraps around and then you get rid of this. And then you'd keep going. So you'd say get rid of the 1, get rid of the 1. Now you're looking at well, okay, let me actually just not skip any steps. So you're looking at this one and this one. You say, which one do I want to get rid of? Doesn't matter. So get rid of this one, go here. Okay, now the 1 is less than the 4. Is that how that would work? You wouldn't want to do that, because you would just immediately... And I don't think it makes any sense to say, would I rather go to a 4 or go to a 1? I don't think that's right either. Because there's a world where like these are the highest 2 elements. You wouldn't want to get rid of them. I mean, you could have like a dictionary leading to linked list nodes and then like sort the dictionary. You could say like, what's the... yeah, I guess you could do that. You could just literally simulate it and be smart about how you're simulating it. So you'd say, okay, what indices are what's the next largest index? Is that overthinking it? I think even that's overthinking it. Oops. Oh, okay. Man, this is where my rustiness is coming in. You just want to greedily say, what if you went backwards? What if you started with the largest? You said, I know I have to merge this with something. Okay. And then I guess of the two things next to me, you could just say merge this with the second largest thing. I think you could always say that, because you could say, like, even if it's not next to me, like this, I will have merged everything below that with this, or something in between. Okay, and then if you're selecting two indices and it's circular, you've kind of made one delineate, you've made like one partition. You have this and you have these. And then you could do the same. That sounds like a headache, but I don't think it's that much of a headache. I think I'm just like, don't wanna write it. I'll look at D and then I'll probably code that out. Marble Council. You have a multiset A which consists of n integers a1 through n. You would like to generate a new multiset S through the following procedure. Partition A into any number of non-empty multisets A, x1 through k. Such that each element of A belongs to exactly one of these multisets. From each x sub I, choose one of its modes and insert it into S. Okay, count the number of different multisets that can be generated through this procedure. Interesting. Please note that the number of different multisets is counted, which means that the order of elements does not matter. However, the count of each element does matter. So 1, 1, 2, 1, 2, and 1, 1, 2, 2 are all considered different. Interesting. Well, this feels like almost like some kind of weird pick, like DP, or like it's kind of like, where are you drawing this partition? If you said, what if your kind of like choice you were making was, what's the next multiset X that I want to extrude? And then you're going to look at the number of elements that have the same mode. And then keep going on the remaining multiset that you have. But I think the time complexity for that would be completely unreasonable. It would be like 2 to the n. We do get O of n squared. That's like pretty big. I think that means that there's going to be some divide and conquer stuff that comes into it. You could maybe even do O of n squared log n. But I'm going to think about this one again. So you always want to take the next best choice. I think I'm overthinking this. I think you just throw this all in a heap and you're good to go. Because you just say, okay, 1, 1, 4, 5, 1, 4, 1. Oh my god. My enemy writing 5s. You would just say, okay, well, like, take a heap of all the pairs. And then you'd say, okay, choose the pair with the best cost. Let's say 1, 1. And then you'd have this heap. You'd say, does it exist? Yes. Okay, if it exists, get rid of it. And and then get rid of each of these, and then put in the maximum, get rid of 2 new ones. Like that. Yeah, you just say do both of these exist. Okay, that's all it is. I'm glad I stopped thinking about this and came back. I feel like I gotta start using Chrome for dark mode. Maybe I could just do that right now. Perfect. Shit. Okay, I guess I need Firefox for that. So what do I get? N, and then I fill up A. Looks good. How do you set... all bits to 1. Dot set. I actually really don't want to do that. CNIDI equals 1, because it's going to take 2 to the 5th each time, or 2e5 each time. Okay, CNIDI is 1. For I from 0 to n. Something something priority Q. This is going to be the maximum of the indices index 1, index 2. Priority Q. God, what is this? Tuple. Int. Vector tuple. Int. And then I think I want greater tuple. Int. That sounds right. Okay, so h dot in place. Okay, I got the maximum of A at I and A at J, and I and J. J is equal to I plus 1% N. Perfect, okay. So now I could say auto Xij is equal to... yeah, actually, I'll show you right now. I have, I just live streamed to YouTube because every once in a while, yeah, like someone's like, I'm curious about this VOD. I specifically made another YouTube channel just for this, Brandon 2, because this is pretty low quality content to most people. I don't really want to like flood my original YouTube channel with this. So if you want to watch it, that's the place to do it. But yeah, thanks. This is a good one so far. This one, once I realized it, I kind of understand it. But Q4, I'm still kind of thinking about, or D. That's my Leetcode talk coming out. Okay, let's see. Equals h dot top print x I j, and then I'll say if test case doesn't equal 1, return. Okay, let's see if it does at all the right thing. So it said a difference of or not a difference, a maximum value of 2. Yeah, I could just give it to you right now. Okay, this is saying a maximum value of 2 with index 0 and index 1. Is that right? Yeah, that seems right. The 1 and the 2 are next to each other. Am I? Nope, I'm not looking at the right problem. That did seem right for that, though. 1, 0, 1. Okay, that seems right. I've been looking at test case 3, so I guess I'll plug that in. It should also say 1, 0, 1. If I get rid of the first one, then it should be 0, 1, 2, 3, 4, 5, 6. 6, 0. It should say 1, 6, 0. Perfect, okay. So this looks good to go. I guess I'll say res 0. While not h.empty. Auto xij is equal to h.pop, h.top, h.pop. I might as well just make this an LL, because I'm going to be adding LLs in. I feel like it could get a little bit sloppy if I'm adding ints to an LL. I feel like I've run into that problem before, and I'm weary of that. In fact, fuck it. All of this is an LL. Any value here is an LL. Okay. h.pop. Now I want to say if seen at I and seen at j, then if A at I is less than A at j, swap I and j. So from here on out, I is the larger element. Actually, I don't think I want to use seen. I think I want to have like next and previous or something like that. I want to say from a given index, let me get back to Excalibur. From a given index, like if you're here and you've removed this and this and this, you want to say, okay, the next thing here is this, and the previous thing here is this. You don't even really need the previous, you just need the next. So the next would have been that, and then let's say like the next was that, and then like this gets deleted, so now this dot next is that. And then this gets deleted, so now this dot next is that. And then this gets deleted. So now this dot next is that. Yeah, I'd rather have that. Because I'm going to need to set the next, which might be like out here. And I can't just say like +1. So right here, I'll just say next. So next at I is equal to I plus 1% n. Clean that up. Okay. Oh. Okay, now here all I need to say is if j is equal to, or if next at I is equal to j, then swap them. Mosquito in your room? That's terrible. I don't even mind the mosquito bites. I hate when they fly right in your ear and you like, it's like a jump scare. You hear that like whining out of nowhere. Okay, if A at I is less than A at J, swap I and J. I think I need to be careful because that's going to kind of mess up the dot next thing. And actually, I'm fairly sure I do need a previous. Prev, so J equals that. Next at I is J. And prev at J is I. So I really am just recreating a linked list. There's not really any other way to put it. I think I'm just going to say... well, first off, if next at I doesn't equal J, just continue. There's no reason to have that needless indentation. Res plus equals X. Okay. If A at I is less than A at J, then J is the one that takes over. So, and J is the later element, always. I think I also, I mean, I think I kind of just want to say, like, if I equals J, break. Because I think the way I've set this up, they will kind of infinitely go. Yeah. Which means h.empty will probably never go through, but I'm not going to think about that. If A at I is less than A at J, this is the world where you have I is pointing to J, I dot next is J, J dot next is something, something dot next is I, also J dot prev is I dot prev is something, and something dot prev is J. So if J is the larger of the two, you're saying J dot prev is I dot prev. And the thing before I dot prev dot next is J. Okay. Alright, yeah, it really is just linked list logic. So prev at J is equal to prev at I. And next at prev at I is equal to J. Or else, this is if I is larger, so next at I equals next at J. This is the kind of thing that really should be muscle memory for me, but it's been a while. And prev at next at J is equal to I. Okay. And also, with these... I think it's gonna look weird. Maybe this is needless. If there's an error, this is the first thing I'm gonna change, but right here I'm just gonna say J equals I and I equals J. Alright, I don't need this one. No, this is really weird. H dot in place. Max I next at I, A at these. No, except J, because this is the one where J is larger. And place that, and J, and next at J. And the same thing, but prev at J. So I'm saying hook this up with the thing after it now. And then do the same thing with I. Okay, that looks good. I set next, I set prev. I add res. So it should be good. Okay, it's very much not good. 56. What's happening here? 101. 160. 402. So it decided... Okay, and then it gets stuck in this weird loop where it says 523, 523, 523, 523. So what is happening there? Oops, sorry. 0, 1, 2, and 3. It's saying 4 and 5 go back and forth. And then eventually it says 5, 3, 5. So then it says 5 and the next 4. Weird. I feel like I could almost just use like a set for this. I feel like I'm wasting so much time on this. I guess it will make 2, right? So I think I want to say like if next at I doesn't equal prev at I, then do this one. Because I think you could land yourself in a situation where you have 3 of them. So this points to this, 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 and this points to this. And if you delete the middle one, you would say, well, now this points to this, and this points to this, and this points to this, and this points to this. But all of a sudden, you've tripled the amount of pointers that you actually need. Right? Wait, is that true? No, that's not how that works. I think there is a problem, but yeah, I don't think you triple it, because I think you'd say that goes there, that goes there, goes there, goes there. So you'd say, okay, delete this. This changes to here. This is never going to be referenced again, so it doesn't matter. And this changes to here, and this is never referenced again, so it doesn't matter. And I think it looks like what's happening is you can stack these up and do a bunch of... You can have a bunch of 5 and 4s together. I wonder if it's good enough to just have like a little safeguard like this little if statement. So I'm saying, I think I want to say, if this isn't already the case. Or no. I want to say if prev at j, I think it might just be this. It's worth at least checking. No, It's not this. Damn, that's really frustrating, actually. Am I crazy? What's the... Why does this seem like just a completely impossible wall when this is like an obvious, simple implementation detail? So you're saying get rid of this. Now this point's here. Now this point's here. Now you only have one more thing you can do, which is these two. So get rid of this. And then now this should all just point to itself, which is fine. And then it would skip it, right? Or at least that's not the problem here. I think it's this. So it's saying 0 and 1, 0 and 6, 0 and 2, okay, that's all fine so far. Oh, I think it's that I need to say just or private j is not equal to I, because I never actually reset these. Okay, there we go. That was the problem. I was like, whew, thank God. 6 to 19. Sorry about that. Looks good. I don't know. If it fails, it fails. Fuck. Okay. I feel like it's going to be another weird bullshit thing. What happens if I just had 1, 5, 1, 1, 1, 1, 1? So the answer should just be 4. There's not really any two ways about it. Okay, if we throw a 2 in there, the answer should be 5. Okay. 2 2s, the answer should be 6. Because you'd say, get rid of these 2 1s, that costs 2. Get rid of this 1, that costs 2. Get rid of this 2, that costs 2. Teach me, senpai. PewDiePie. I wish I were in a teaching position right now, but it's not looking that way based on how this problem's going. If next at I doesn't equal prev at I think that does not matter anymore and is kind of not worth pointing out. Like, I don't think that should ever come into effect. You're doing great. Thank you. Let's see. If we have 2, what does this do? This should just immediately eliminate one of them. Okay, it does. What if we just have 1? This should just not do anything. That seems right. It should be 0. It also can't happen, I guess. Okay, the one other thing I actually need to test is what if we had 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we have a really big number that's going to overflow. What happens? No, it doesn't overflow. Maybe I counted wrong. No, looks fine. Okay, damn. So it's not an overflow problem. Next to I at J, prev at J is I. You're throwing in all the pairs. I think that's okay. I think actually there could be, yeah, there could be a problem. Okay, so this is very slight, but I'm saying max A at J, A at next at J, and then I'm saying J next at J. That's fine. But here I'm saying J prev at J, but all of this code assumes that it's I is the first thing and J is the thing after it. So that falls apart if I do it that way. And that's the same here. And for some reason I said J, which is just wrong. So that was just a typo. Prev at I and I. Alright, let's run it again. Should be fine here. Okay, thank God. What was this one? The multi-set one. A belongs to exactly one of these multi-sets. Each element of A belongs to exactly one of these multi-sets. So you're partitioning A. I already read this one before, and then I went back to C. So it's saying you have a big list of numbers. The order doesn't matter. You have a bunch of numbers. There can be repeats. Partition them into a bunch of subsets. Sub-multi-sets, because there can be repeats. But partition it into a bunch of subsets. And then from those sub-multi-sets, choose one of the modes. So one of the most frequent elements. If there's a tie, you can choose multiple. If there's just one, you have to choose that. And then insert it into S. Count the number of different multisets S that can be generated through the procedure. It's actually pretty tricky because, like, if, say you had your final S was 1, 1, 2, you could have one of your X sub-multisets give a 1, and another one give a 1. Or you could have like a different 2 give 1s. Like I think you can't, like in my mind, it's going to be difficult to like try and build it out. Like I think the initial kind of temptation is to say, okay, if you have 1, 1, 2, 2, 3, 3, 4, 5, something like this. And then you need to partition these into a bunch of stuff. So you're going to like do this 0, 1, 2, 3. These are going in here, and then all these are going to give their possible contenders, and then you're going to get S. So I feel like there's a world where you say, okay, we'll just take one of these, and kind of without loss of generality, like all of these other things are going to kind of equate to this one. So just look at what you can do when you build a multiset, and then say, okay, how many ways are there for this to, I guess if you were really starting from like first principles, you could say, what are all the options for this? Which you can't actually like enumerate through all of them, but you could at least be like, what are all the ways where you can like have a 1 come out of this? But the problem is, let's say S, or the number of ways, number of distinct S's. Like one distinct S will have a 1 and then a 2, right? Let's say like both of these 1s go in here. That's the most frequent element, so it spits out a 1. And then like the 2 goes in here. And then a 2 and a 3 goes in here. So you could have a 1, a 2, ... Or, and that could have been the 1 came from here, the 2 came from here. And then let's say the 3 came from here. Or you could have had, there's something else in this one. A 4 comes from that. But the 2 comes from here. And then it would be like... So I think you can't really go based off of these specific ones. I think I'm going to have to be a little bit more clever than that. I think it has to be like... You could say something that's like, how many ways are there to include this many of a number? Something like that. So if you looked at just the ones, like how many ways are there to have a single 1? Well, that means you need a multiset where there's at most 1 of a value, and then that 1 can come from that. There's like the frequency is at most 1. Or like if you wanted 2 1s, you need 2 multisets. Where like this just contains the 1 and that just contains the 1. Or it just contains like a 1 and a 2 or something, I don't know. Whoops, sorry. Still getting used to that. One, 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 two, two, two. Maybe it would help to look at these examples. So 1, 1, 1. The answer is going to be 3. That makes sense. Because really you could have, you put all of them in the same multiset. You get 1. You just make 2 multisets. One of them has a 1, one of them has 2 1s. Then you're going to get 1, 1, or they're all in separate multisets. And then you get 1, 1, 1. 1, 2, 3, there's 7 options. That's like a little less trivial to me. So I guess the answer was like, you just have 1, you just have 2, you just have 3. You have, well, isn't it just like any combination really? It's like 1, 2, 1, 3, 2, 3, or 1, 2, 3. Oops, I keep doing that. 1, 2, 2. The answer is 4. You're always going to have a 2. There's no way around that. It is the most frequent element in the entire thing. And moreover, there's more 2s than there are anything else. So no matter what you do, you're going to have an extra 2. So you could have 1, 2, 2, 1, 2, or 2, or 2, 2. And then these other ones I think are not really worth looking at right now. These feel more like when I have working code, that'll be useful. The way this problem is said really makes me feel like, by the way, the link doesn't work. Oh, okay. That's probably that's funny. That's probably my, like YouTube Studio link or whatever they call it. That's funny I sent that. Okay, I'll send it to you later in Discord. S is empty. For each exabyte, choose one of its modes. Yeah, I really get the sense you have to go off of like how many different ways are there to have each number of ones? And then go from there. So what if what you said was like start from the bottom, look at all the ones, figure something out, look at all the twos, figure something out, and so on. And we have like a lot of leeway. N is 5,000. That also tells you the highest frequency is 5,000 because there can't be more elements than there are total elements. So what if you had some sort of like DP where you said, okay, DP at I at J is equal to number of combinations such that yeah, I don't know, like all elements in your array are greater than or equal to I. So you're looking at this point forward, and the maximum frequency is less than or equal to J. You could have something like this, and then you could just parse the array. You could sort the array and then parse it from smallest to largest. So right here you could say like, how many ways are there to have like 4 ones? If there's 4 ones, okay, I think it's not the max frequency is less than or equal to J, it's the max frequency is greater than or equal to J, probably. Because for example here, if you said, how many ways are there to have a single one? That means that you necessarily grouped all of these ones. No, it doesn't quite mean that, does it? It could mean that. So there might need to be some prefix sum trickery, which is kind of rough. This already is like a pretty stark formulation though. 2, 2, 2, 3, 3, 4. So if I look at the case of 1, 2, 2, I'm just going to look at 1, 1, 2. So if I say I want to have a single 1, that doesn't actually mean both of these need to go in the same X, because you could have had 1, 1, 2, and then the 2 is chosen and the 1 is chosen. And both of those would result in a single 1. The maximum frequency is greater than or equal to J. There's really 3 things you can do with any given element. There's either start your own subset. There's include as a non-mode. I guess there's 4 things you can do. Include as a definitive mode or a possible mode in some previous subset. I think I'm on the right track with this like 2D reconciliation where you sort it, but the count matters. What if you had like 1D DP? Excuse me. No. I think you kind of need 2D. You could say, with this frequency of this element, how many ways are there to include this in a previously created X? I'm losing the plot a little bit with this one. Wow, people did not figure this one out. Oh no, never mind. I didn't realize it updated it in real time. I feel like this has to use a prefix sum somehow. I'm getting that impression. So you're saying from I on. And then this is kind of the mystery one here. What does J represent? Because this feels like the number of combinations from I on. Doesn't that completely matter, like, what the previous choices were? So maybe I'm barking up the wrong tree here. I'm gonna read E and come back to it and let it incubate. Given n integers within the range 0, 2 to 30, you can spend 1 coin to increase any a sub I by 1. You can perform this operation a number of times. You just solve Q queries. For each query, you're given an integer C, also in the range from 0 to 2 to 30. You would like it if there exists a sequence B of length n of the following properties. Every numbers within lower than a sub I and everything XORed together is C. Calculate the minimum number of coins you have to spend such that there exists a suitable B. I see. Okay. This was like a Gaussian illumination thing, which I'm not great with, so I doubt I would get this. This seems like you need to figure out, like, what's the smallest element that's not reachable? Or yeah. What if you went by the mode frequency? So like, oops. So like the number of ways from this point on to have a mode of 4? That doesn't make any sense. It's just tough because, like, let's say you're here in this DP formulation. You're like, at this point on, what's the number of ways to have something? That just, like, necessarily relies on prior choices. If you had everything thrown into a single subset, sub-multiset, 1, 1, 1, 1, 2, 2, then that would always be 1. No matter what you did, it's always going to be 1. That's different than like if all of these were separate and then you could do something else with that. Maybe that doesn't matter. Maybe you could say, no, that's weird. That doesn't make sense. Maybe you could say the number of ways to create a mode of like less than 4, if you put all the ones in the same thing, all the ones into the same multiset, you could say, what's the number of ways No, I just still think that's weird. What if you just decide, what if you just said there are n subsets, straight up. They're all empty. It says any number of non-empty multisets, blah, blah, blah. I'm saying it's exactly n, and when it starts, they're all empty. And then you progressively make choices. No. I don't think that makes sense. What if you said, okay, what if you said, okay, I'm not going to record any information about my previous choices because that's not really compatible with DP. And then I'll say, okay, let's say I have 2 2s left or 3 2s left. So I'm at index the 2, I'm at index 1 is what it would be, and there's 3 of them left. And I'm saying, how many ways are there to make 2 a mode? I guess that doesn't seem right. I don't think that works. Because again, like, yeah, there are all the possible choices prior to this, so it's, in a way, it's like you haven't really made a choice because you have to account for every choice. But in another way, it's like if you have to account for every prior choice, I don't think you can just like treat them all as amorphous. It would have mattered if you put 2 1s together and 2 1s together as opposed to just all 4 1s together. I'm really coming up against the wall here. So what are the ideas? Go number by number. Assemble number of possible suffixes under a condition. That's one option. Another option is, I guess, you go X by X, but that doesn't really make sense. Because what the hell does that mean? I guess you could go X by X and you could say, what's the size of this thing's mode? How many modes could this have if it took up this many elements? No. I mean, I think I'm actually like getting stuck on the mode thing. So like if we had like, let's say 5, 4, 4, 9, 9, 9, this just directly correlates to 1, 2, 3. The original values just completely don't matter for this problem. So if we look at this, 1, 2, 3, in this world, mode corresponds to the maximum value in a given subset, and then I'm just attributing points from each of these. Man. I think I'm thinking about this wrong. I think if you had this 5, 4, 4, 9, 9, 9, you could always include 1, 2, or 3 nines. The question is, can you include, how many ways are there to include 0? Right? Or can you include 0? I think everything else is not relevant. It doesn't really matter how many distinct X's there are. I think that's, okay, yeah. That's like a lot of fluff that I'm not really, I think it's really distracting to me. So you could always have 1, 2, or 3 nines. You just put them in their own group. And then the question is, can you have 0? You could have 0 if there was a group before this that had at least 3 of a distinct element. So then you would get to dp at I at j. Number of combinations from this point on where you're at this number and j is the previous maximum that you've seen. And the maximum would just be yeah. I think it's still more complicated than that though. Because if you had like 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And you're saying, okay, I can have 1, 2, 3, or 4, or 5 twos. That's true. Can I have 0 twos? Yes, but there's only one way. It's if all of the ones were together. But what if we had like this? So now I'm saying, is there a way to have 0 twos? How many ways are there to have 0 twos? Or how many ways are there to distribute twos? And then this question is going to be like, okay, I equals 1. That's the case because we're at the first 0 indexed distinct element. And then j is going to be up to 7. 1, 2, 3, 4, 5, 6, 7. And this would mean, yes, you can have 1, 2, 3, 4, or 5 twos, or you could have 0 twos, because the largest thing is a 7. But then if you had j equals 6, how many ways are there to have reached j equals 6? I think it won't matter. It's all just you had 6 ones. Or, yeah, you had 6 ones together and another 1 separately. So that's when you use 2 ones in your S. If you have j equals 5, then I think it gets more complicated because you could have had 2 ones or 3 ones. Because you could have said, these are all together, that's true, and these are together, or these are separate. So therefore these need to be prefix sums across j. Because you're saying when I'm at this one element, no, is that right? I don't think this prefix sums across j. This would just be if you selected 5. You need to be smart about how you calculate this. I guess the rest of it doesn't matter. You're just saying it's... See a PewDiePie. I guess you're just saying if you had selected 5 ones, then you can have 1 or 2. If you'd selected like 3 ones, then you can have 1, 2, or 3. Like, or no, I'm sorry, you could have 2, 3, or 4 other ones. But this all needs to kind of be O of 1. I think it's important to say, like, let's go back to this example. So if you chose 5 ones to be grouped together, that's now your maximum, because this is the first element you've ever seen. So you have not seen 5 before, so that's the best you can do. And you could either have these be together or these be separate. That means, I think that just means you multiply this entire thing by 2. As opposed to, like, if you had 6 ones, there's only one way to do this, which is 6 ones and then the other 1. Or if you had 7 ones, there's only one way to do this. So this would just be dp at ij plus equals dp at I plus 1 at 7. Okay, if you had this, according to what I'm saying, this is maybe 3. Yeah, this would just mean 1, 2, or 3. You could have, or I guess times 4. You could have 1. No, it's just 3. This is 3. So it's, if there's no more, you have 1. If there's 1 more, you have 1. 2 more, you have 2 options. 3 more, you have 3 options. But then the moment you get to here, you would only have 3 options, because you wouldn't be able to group all these together, or else that would have been your largest thing. So there's going to be a little bit of math. So it's going to be a prefix sum across J. I was right. Because what you're going to get is something, let's say dp at 0 here, when you have 7 comma 5, is going to be equal to dp at 1 at 7 plus dp at 1 at 6 plus dp at 1 at 5 times 2 plus dp at 1 at 4 times 3. That's this. Plus dp at 1 at 3 times 3. I guess it's just the minimum of this. It's the minimum of x and n minus 1 minus x, I believe. And then if you had 2, all of these could either be grouped in 1 or 2. So at most, you could have 1, 2, 3, 4, 5. At least you could have 3. So 3, 4, 5. And then if the maximum size is 1, you can only have one of these. So I think I'm just going to kind of try to brute force through the logic in the recursive call for... Well, they're all 3. I mean, I don't think that changes at all, right? Like, that's just going to be a static value. So here I'd say now there's 9 of them. So DP at, if I said all 9 of these are together, there's 1 way. 8 of them are together, there's 1 way. 7, there's 2 ways. 6, there's 3 ways. 5, there's 4 ways. 4, there's also 4 ways though. Right? Because you'd say these 4 are together. So then I could either include 1, 2, 3, or 4 outside of this. No, that's not right. I could either include 5, 4, 3, or 2, but these couldn't all be 1. Because if they were all 1, if these were all together, then that would have been the largest partition. Okay, so according to my thought process, this should also be 4. So there's 3 together. That means here you could have 6, 5, 4, or 3. Or 2. Shit. Six, 5, 4, 3, or 2. But they can't all be 1. What's the maximum? What am I saying? What's the maximum is just this number. So 6. That's the maximum amount of additional groups you can have. The minimum is going to be the minimum groups you can have before one of them needs to have 4. So I guess that's just going to be 6 over 3. Which according to that, this should be 7 over 2. So it's going to go 7 all the way down to 3 or 4. Yeah, you could have 1, 2, 3, and 4. So it's 7 over 2 rounded up. Okay. That's actually not good because this was kind of able to be turned into a O of 1 formula. This is going to be a lot harder. I mean, I don't know. I feel like this is like a solvable question. How many ways are there to choose from n elements such that the maximum is k? The maximum partition is k. I feel like you just pre-calculate this. How many ways are there to choose from n elements so that the maximum partition size is k? I really hope that's not inclusion exclusion. String numbers of the second kind, the number of voice partition a set of n objects into k non-empty subsets. No, I don't care about that. The general formula for n objects, k boxes, and a max of m in each box would be this. Not useful. K partitioning the array, we split into the array. K contiguous subarrays, no. Number of ways to choose from n elements such the maximum partition size is k. Refers to the number of partitions the number of k combinations. The number of k combinations. No, that's not useful. I'm not about to reinvent this. Deputy be the number of ways to partition an integer I into parts. This saying just do DP, none of this combinatorics crap. I guess. All items into K groups, don't care about that. That's just stars and bars, right? Set partitioning with max partition size. Number of possible partitions 1 through n into subsets with max size m. Thus all subsets have a number of elements less than or equal to m. This is called the restricted bell numbers. They have been studied here and here. The link you put in the form deals with exactly restricted Stirling numbers of the second kind. They're denoted by something. In general, you're interested in some from 1 to n of something. I don't know. Things that I should follow on the implementer's recursive function in MATLAB. Solving for n equals 25, m equals 4. I got some big number. This shows that it's almost certainly not feasible to solve as a binary linear programming problem. Written as that. Okay. Alright. So what do? I build the Stirling numbers. I don't see why this wouldn't be something like O of n squared. So I build all the Stirling numbers. I build a prefix sum of all the Stirling numbers. That gets me the restricted bell numbers, which is exactly what I'm looking for. And then I don't even think that solves the problem, though. Because I still have dp at I at j. And then this only really allows me maybe. I mean, I need to parse this in O of 1, so I don't think it's good enough. Also, I actually still think that this is a separate problem. I think I just kind of wasted my time. There's no way I'm going to implement FFT for this. There's no way that's like what's going on here. Oops. Yeah, people are really struggling with this one compared to even E a little bit. This really feels like a Gaussian elimination thing. I'm not going to think about that. I find those to be really ungratifying to code out. And I don't think I'd get it in time at this point. Well, maybe I'm overthinking this. Because dp at I at j, you know that I times j will always be less than or equal to n. So I think I can kind of use this. I think I'm overthinking this wildly. I think the fact that I times j will always be less than or equal to n is the key. Right? No, that's not true. I times A at I times like these, the sum of these will always be less than or equal to n. So actually, yeah, if I just parse by these, I should be fine. Yeah. Okay. Finally ready. Marble Council. Broken Bambino. I'm working on the last Codeforces div too. With like 10 minutes left, I finally came up with a solution for D. It's tricky. Something like this, right? Yes, okay. Four, three, two, one, blah, 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 blah. I think I just want to redefine N. I know it's not great, but whatever. I'm never going to reference that again. No, that's actually not true at all. I'm going to have M be the maximum possible frequency of anything, and N be that. Okay, so 4, 3, 2, 1. It's saying there's 4 1s, 3 2s, 2 3s, a 4. If I go 5, that should be 3 3 3 1. Yeah. Okay. I need a big DP table. Can I do LL? What is it, 2 seconds? I think that's fine the way this works out. I don't think I'm gonna get this in time, which is a shame. It was an interesting one. Yeah, I'm not gonna get this in time. That sucks. Hi. I'll try to code it out though. Although I do have to go at like 8:20. Hey. You got this. First step is believing. I don't believe I can get this one in 8 minutes. That'd be pretty cool, but... So let's see. I'm saying start at the end, go backwards. I mean, maybe I could even just do this recursively. Is that... That seems like a bad idea. That seems like that would not pass. I'll try that. I actually have a shot of being able to code that out in 8 minutes. Okay, DFS is something. And then I'm just going to say like res is equal to DFS of, I'm starting at 0 and 0, and I'm calling DFS itself. Okay, first things first, if dp at I at j does not equal -1, return dp at I at j. Also, if, I think I'm just gonna say int n, int m. Kind of sloppy, but whatever. Okay, if dp at ij is not -1, return dp at ij. That means I have to set that. So for I from 0 to n, for j from 0 to m, dp at ij equals -1. Great. So there's one more though, which is like if you're done. So if I is equal to n, return 1. You've made one successful thing. They've all got to be LLs though. I can't cast them. Okay, that's that done. So what I'm kind of saying is like try selecting literally every amount that you can as the maximum frequency. Oops. Yeah, 5 minutes, I don't know. Try selecting each one you can as the frequency. So 4K from 1 to A at I. The upper bound is going to be the most... Oops. It's going to be the most elements you could choose. So if you took 1, for example, you could have 1, 2, 3, 4, 5, 6, 7, 8. So it's just A at I minus K. The lower bound is going to be a little more complicated. I think a lot more complicated. If you took like 2, you're saying, okay, there's 1, 2, 3, 4, 5, 6, 7. Can I get away with having 3 groups? No, because a group can only be at most a size of 2. So I'm going to say A at I minus K is going to be this population. And then this population, I think it's just over K rounded up. Yeah. So I think what I could do is say A at I plus K over K minus 1. This should just round it up if I remember correctly. But someone that like also programs like this, let me know. Because I feel like people write this a lot. Plus K over K minus 1. Or you could say minus 1 over K plus 1. I think those are the same. Okay, so here it should say, let's say I took 2, K equals 2, A at I equals, this should be 9. This will say, okay, the remaining is 7. So I actually should say A at I minus K, minus 1. So 7, minus 1 is 6, over 2 is 3, plus 1 is 4. Okay, that's fine. So the least I can have is 4, the most I can have is 7. So upper bound plus 1 minus lower bound is the number of distinct elements I can have. I'll snooze that. So I'll say res plus equals is something percent mod. So res is equal to res plus upper bound plus 1 minus lower bound times dp at I plus 1 at max j and k, because you may have just increased the amount. Okay, well in theory that should be it, although dp at I plus 1, no, this will just say if I equals n return 1, so that should be fine. -2. Damn. Okay. How did that happen?
You're listening to the NTS Guide to taking you on a journey through.
I think it's probably time. No, I have 1 minute left. Maybe I can find this bug. Return 1, return res, dpnm, upper bound and lower bound, they're both the same. Three, 3, 3, 1. Times dpi plus 1. Oh, wait. Well, I never actually call... I think this is the problem. I say dp at I plus 1. I don't... I don't know what I'm thinking here. This should not be that. This should be dfs I plus 1 max j and k. Man, I'm gonna feel bad if this literally just works. I'd be surprised. I'll feel bad if this doesn't work. nm dfs. Okay. I kind of want to do my example here. So 1, 14. So 9 1s, 5 2s. Really? It has problems with this? Oh, that's why. Okay, 9 and 5. So it says you're at index 0. You have seen a maximum size of that, which is fine. So then it tries 1, 2, 3, 4, 5, 6, 7, 8. I think it should try 8i plus 1, right? It can try all of them. The upper bound is 8, the lower bound is 8. So this only has one option, that's right. The upper bound is 7, the lower bound is 4. So this has 4, 5, 6, 7. I think that's right. Right? That is this case. Yeah. The upper bound is 6, the lower bound is 2. That's right. The upper bound is 5, lower bound is 2. These all look good, I don't know. I don't see why these wouldn't work. So it's calculating this right. I plus 1 max j and k nm dfs. And then it's saying, okay, now pass this up. Yeah, these are like actual values. These are never anything. Well, that's just right now, though. Oh, wait. 144. That's like an actual answer. Hmm. Three through 3-1. It's straight up saying 8. When did you start Codeforces? I think I made my account like 2 or 3 years ago. And I did like one problem because people were doing it in a Discord server. And then I started like actually doing Codeforces maybe 6 months ago. I've been doing Leetcode for a long time though. Difficult to get motivation being employed. Are you saying it's difficult to get motivation to become employed, or you're employed so it's hard to be motivated? Okay, 111. It's saying 1, which it shouldn't. It's saying if you're here, there. Well, I can just see it. So I is 0, J is 0, K is 1. Upper bound and lower bound are both 0. That's fine. Okay. This all looks fine. Especially because I feel like I suck. I'm employed, so it's hard to be motivated. But maybe I should put in the effort for FANG or Big Pay Company. I mean, I wouldn't be too hard on yourself. Like, I think that's a very possible ambition, but the job economy is like very bad, especially in the tech market. So I think, like, I mean, what can you do with that information? I don't know how, like, actually worth it that is to consider. Like, how much does it really change how hard you should try, in my opinion? Like, you always try your hardest and all that. But it does mean that, like, you can't, like, I wouldn't beat yourself up. I don't know if, like, you suck because you can't get into FANG, you know? But maybe I should put in the effort. Oh, I already read that. I mean, people do. I don't know. I also don't know how much, like, this level of competitive programming, I think unless you're aiming for an HFT, I don't think it really matters. That's my understanding. No, I'm not. I'm just a regular guy. This is interesting. I like print I J res. Maybe this is a problem with like the dimensions. So it's saying there's one option if you're at Okay, I think I know what the problem is. The problem is that I'm not actually accounting for, like, the whole point of this was to say, yes, you can always have 1, 2, 3, 4, 5, 6, 7, 8, 9, whatever ones. You can always have all these ones. Can you have 0? You can never have 0 of the smallest thing. Can you have 0 of this? So I need to account for if you can have 0. So I think what that looks like is if something res equals res plus something percent odd. This was the part I was missing. And then this would be DFS I plus 1 J N M DFS. And this is if J is greater than or equal to A at I. So for example, if you used 5 1s, if you said I have a grouping of 5 1s together, well now this grouping of 5 2s could possibly not be the mode. So that accounts for that. That's why the number is drastically too low. I feel like there's another thing I'm forgetting though. Right? What am I forgetting? Maybe not. Maybe it randomly works. 4? I don't think that's right. I think it's supposed to be 7. Right? 7, 3, 4, 111, 126. Which I guess makes sense. This is kind of saying 2 to the power of... Oh, I know what I'm forgetting. No, not really. It's that the very first thing could also be nothing. You could not include the first element, but the way my thing works right now, like, you'll always include the first element. You'll always include this 1 because you're going into it saying, like, I have to include that. How do you possibly get around that? I live at a H-cool city, so to be honest, after CS salary, it's not too much. Nice. It's tough right now. I mean, so many people are talking about the big bubble. Really calls into question whether it's worth, like, or how much it's worth pursuing AI. I think it's probably pretty worth it. How do you get around that? Man, that's like such a simple thing, but there's no element that you have to include. I guess you could just hack it and you could be like, okay, look for the largest element. No, maybe you don't even have to do that. Okay, you could sort it. Okay, there's 2 options. This is a little bit confusing, but if you have, let's say, 1, 1, 1, 1, 2, 2, 2, 2, and a bunch of other crap, but nothing here, there's no point in writing it in this way anymore. I'm too in deep with this problem to be writing it like that. You have 4 1s, 4 2s, everything here is less than 4. So this is one option. The other option is you have 5 here. Or like this, where this is indisputably the largest thing. If this is the largest thing, you do have to include it, and then this just works as normal. If this isn't the largest thing, then this is the same size. So you could say, okay, well that's DP at I plus 2, you're starting here. The only way to not have included this is if this is also, if this is a size of 4. So then you'd say DP at I plus 2 at A at I. This is weirdly written. DP at 2, at A at 0. So you're saying, I'm actually just going to start here, and I'm going to have already devoted 4 to the sole purpose of making sure the 0th thing didn't count. My god, is that convoluted. Okay, what that means is I need to... Let's pull this up. I'm going to pull it up in Chrome so it doesn't flashbang everyone. Sort, we got first, last, compare. Great. Return A is greater than B. Is it? Comparison function which returns true if the first argument is less than the second. So I just want greater than. So I'll say sort A plus N, and then right, something like that. This will now sort it. So if I had this, it should now say 2, 1 and not 1, 2. Perfect. Okay. So that's res. If if n is greater than 1 and A at 0 is equal to A at 1, this is the case where you have to like skip the second thing and the first thing. So you'd say res is equal to res plus DFS of 2, A at 0, and MDFS. This is you skipped the 0th thing. This feels really janky. 2 seems like a right answer. I don't know. 6. Okay. I need to get one more. So what is it not doing here? No. I think this idea that you can just substitute the second with the first, I think doesn't work, because you could also have had 4, 4, 4, and then a bunch of other stuff. In which case you could have designated these 4 to absorb this, or you could have designated these 4 to absorb this. Okay, I'm actually... This is a shame. I'm have to go attend to a bidding war right now, actually. I'm just gonna quickly log in and make sure the one thing I really want is still there. Or I still am like the winning bid on it. That's what I care about. I guess this is a good stopping point. Mostly because I'm about to get this TV for 1/20th the price it's supposed to be. And it's like very expensive. And I want that. Okay, yep. I think I'm still the top bidder. That's good. Okay, well I do have 10 minutes left. So I'll keep at this for 10 more minutes and then I'll go. Okay, you could do one more thing. You could say, I'm choosing to skip 1, not designate anything for that, and also skip 2, because I have to designate everything in order to get this to be 0. Or I could say, skip 3 to skip 1. What? Yeah. I actually don't even see why this wouldn't work here. Why I would get 6 and not 7, but whatever. Or I could say one of these other things that's a... How do I put it? Like here I have 4, 4, 4, and I'm saying, okay, consume this 4 to skip this 4. Now you're starting here. Or you could have consumed this 4 to get this 4, and now you're starting here. But in a way, those are all exactly the same because this is predicated on the fact that all these numbers are identical. So you could just say, consume this 4 to get to this 4, start here. However, keep track of how many 4s there were to have skipped this with, and then multiply by that. Yeah, you just literally... No. Because the moment you do that, if you said, okay, well, they're both 4s, so just treat this like this. The moment you do that, though, you're in really hot water because then you're saying, okay, well, really, I'm swapping these for a moment. And then I'm here. And then I'm going to go forward. But the problem is you didn't actually... I think you would be double counting stuff. Man. Oh, so close. Like everything came together. That's so rough. Maybe I'm just completely on the wrong path. This feels like just exactly this works. Except for this weird thing that's like, what if you skipped the 0th element? You could introduce a binary into this. You could say dp at I at j at k, where k is, have you exceeded the 0th element? Because the moment you've exceeded the 0th element, you get to include 0. You get to skip this 1. God, that's so confusing.
We thought they meant that we were Uranus, but then we asked them what they were, and it said we were a zodiac. And then they kept on giving messages
Okay. No, that's... I see how that would work.
that call
I'm just gonna call it X, I don't care.
we ask repeat
I already used K somewhere else.
of the message rang.
So then here you're saying, yes, I've for sure already used up the first element. I'm fine.
Next night.
Because
The next night at approximately 8 o'clock,
this is the case right here where you're just starting at the first element. This is the case where you're trying to skip it.
saw the star coming out behind the tree, and there it was. The first sign we asked
So here you're saying 0.
Morse code. We all got around and started talking about it. And at about 9:30, the star started leaving. And John Weathers,
So if you have exceeded the first element, if you've covered that base,
what happened? What he called them, he called, told them to do something
X, that
Friday
looks
night
good.
at 8 o'clock.
Yeah, if you've exceeded, if you've accounted for the first element,
Well,
then you're good.
we started
This feels so... There must be a way to do this without needing this X value.
tell him to land here or not, and seems like everybody's against it.
Or else here you're saying try it,
And,
I think just DFS from 1 on,
which they were, and they started shouting,
and then
and it appeared that they were leaving.
right here,
So
if
nobody thinks
J
I tried to go on
is
by myself. And, I got
greater than or equal to A at 0, X is equal to 1. This means, like, if you ever have actually exceeded it, then you can set X to be 1.
Well, then after that, I sent a message to told them to leave. After they left, the next morning, that was Sunday,
But then I need a third dimension for the DP array. You can't just, like, ignore that.
woods to find out if there were any signs of a spaceship, because we had seen them coming up from an oak tree. This was approximately 2:30. We wrote a sign. We told Ann Morris if we weren't here to come after us because we might be in some kind of a jam with them. So then we wrote down on the ground. We went this way, and I wrote down 8 o'clock tonight, 8 o'clock p.m.
I don't know what's going on there. Okay, DP at I, J at X. I guess. Fuck. I think I could literally just say this. I don't think I need this. This is saying you've skipped the 0th element. Can you get away with it? 1, A at 0. Except now this just needs to be 0. Right? No. No, this should be A at 0. Alright, that's my alarm. I'm out of here. Thanks for watching.